Today we're going to be looking at solving systems by graphing. So first let's look at a couple definitions. Systems of linear equations. So when we have two or more linear equations together. Solution to a system of equations is a coordinate which makes both equations true. So for instance, 2, 1 we could say is a solution if we plug it into both of our equations, and if they both make it a true statement, then we know it's a solution. So let's suppose that Thelma Lou has $20 in her bank account and is saving $5 each week. Barney has $5 in his account and is saving $10 each week. When will they have the same amount in each account, and how much will be in the accounts? So first we have to make our two functions, so our system of equations. So if we look at Thelma Lou, we know she started off with $20 in her bank account, but each week she's putting in $5. So her rate of change, or the slope, is 5 times x, and then she started with $20. For Barney, his rate of change or slope is $10 each week is what he's adding, and he only started with 5. So now we need to graph both of these equations to solve it. So if we look at Thelma Lou, start at $20, and we have a rate of change excuse me, of 5, so we're going to go up 5 over 1, and I'm going to keep going, connect my lines. So there's Thelma Lou's progression. Barney starts with $5, and he's adding $10 each week. So looking at our system of equations, our solution is where our two equations intersect, and they intersect at 3:35. So that means after 3 weeks, they both have $35. Let's take a look at solving these three equations by graphing. So first, y equals x plus 2. We have 2 as our y-intercept. Our slope is a positive 1, so we're going to go up 1 to the right 1. I'm going to keep my line going so I can make it as accurate as possible. So then my second equation, we have a y-intercept at a positive 2, but my slope is a negative 2, so it tells me to move down 2 to the right 1. So our solution to the system of equations is where they intersect, which at the x-axis it's at a 0, and the y we're at a 2. So let's look at our second one. Y equals 1. So that means we have our horizontal line that intersects the y-intercept at 1. Y equals x, and there's plus 0 there, so our y-intercept is at 0, and our slope is a positive 1, so we're going to move up 1 to the right 1. Remember, our solutions where they both intersect. They intersect at a positive 1 on the x-axis and a positive 1 on the y-axis. So looking at our third equation, or system of equations, y-intercept at a positive 1. Slope tells us we need to move down 1 to the right 3. And they keep up with that same slope. Then our second one, negative 3 is our y-intercept. Slope's telling us to move up 1 to the right 3. So our solution where they intersect is at a positive 6 on the x-axis and a negative 1 on the y-axis. Let's look at the back side. We want to solve both of these equations, solve system of equations by graphing. So our first equation, we have a y-intercept at a positive 1, and our slope tells us to move down 2 to the right 1. Second equation, we're down to a negative 3. Slope is a negative 2, so down 2 to the right 1. So looking at both of these equations, they are parallel. We have the same slope, different y-intercepts. So as they're parallel, they never intersect. So that means there's no solutions. Let's look at our next one. Y-intercept is at a positive 4. And then we have a slope of positive 3, so up 3 to the right 1. And then our second one, let's put it into slope-intercept form. So we want to add 12x to both sides, because we want y by itself. So we're left with 4y equals, these are not like terms, so we have 12x plus 16. We want to divide everything by 4 so we can get y alone. So 12 divided by 4 is 3x, 16 divided by 4 is 4. So when we go to graph, we're at a positive 4, slope of 3. So this is the exact same line. So that means they intersect at every single point. So that means we have an infinite amount of solutions. Last example for the day. Start by graphing a positive 12. And then our slope is a positive 4, so we go up 4. 1, 2, 3, 4 over 1. And I keep going on the other way. So let's graph our second one. We're at a positive 24. Slope of negative 2. So down 2 to the right 1. So our solutions, where they intersect at a positive 2 on the x-axis and a positive 20 on the y.